Hi, this is Jeff Spence, your Math 135 instructor for the Community College of Denver. I'm doing some examples from 6.5 where you want to find z-scores using inverse norm instead of the table. Inverse norm is accessed by pressing second vars. It's right below the normal CDF. In yellow you can see the function. Basically got to enter in one number. When you use inverse norm, you got to tell the function that you want the z-score, such as the area to the left of that z-score. So if you enter in an area of 0.5, for instance, the area to the left of 0.5, where's that z-score? That z-score is right in the middle. So the z-score right in the middle has area to the left 0.5. That would give you 0. So let's just look at this example. It says find the z-score such that the area to the left is 0.3269. Let me draw a picture for you what that means. So now we know the area, and this time we're finding the z. Now remember, z equal to 0 is in the middle, but we're looking for a z such that the area to the left is 0.3269. That's less than half. Half of the area is on the left side, half of the area is on the right side. So if we want the area to the left to be 0.3269 and it's on the area to the left, that z-score has to be on the left-hand side. Because this area here represents 0.3269, which is less than half, 0.3269. Now I'm putting that 3269 above the number line because that's an area, and I want to know what the z is. Well, we'll use inverse norm, do second vars, inverse norm of 0.3269, oops, jeez. 3269, press enter, and rounding to 4 digits you get 0.4485. So let's move on to the next example. Okay, so in this example we're going to find a z-score such that the area to the right of that z-score is 0.6790. Now remember, we're going to use inverse norm for this. In inverse norm you do second vars and you tell it the area to the left, and that will give you the z-score. So let's draw this picture. The problem asks to find a z-score such that the area to the right now is 6.6790. Now remember, the z-score of 0 is right in the middle, and we want to find a z such that the area to the right is 0.6790. Well, since that's over half and it's area to the right, we actually have to find a z-score on the left-hand side, because this area, this whole area, which is 0.6790, is over half. And remember, half would be from 0 on, but we're from over half, so this z-score has to be on the left. We're looking for this. Well, the thing is that inverse norm only knows how to do left area. So what you have to do is 1 minus the 0.6790. 1 minus the 0.6790, and you get 0.3210. So then we do inverse norm of not of 0.6790, but of 0.3210. And that will give us this z-score, because the area to the left of that z-score is 0.3120, this red area. That's what we input. So we do that, and we get, rounding to 4 decimals, negative 0.4649. So when we have to do find z-scores such that the area to the right or above is 0.6790, we have to do 1 minus 0.6790 to get the area to the left, and then do that to inverse norm. Okay, on our last example, we're going to look at a different problem that asks, find the z-scores that are the ends for the middle 95%. We're going to see this a lot, middle percentages. Middle percentages are useful for confidence intervals when you want to have an equal amount on the right as you do on the left. So the middle percentage problems are going to go like this. Whenever we see middle 95%. You know, if the other language confuses you, just pay attention to middle 95%. Draw your bell curve. Remember, the mean of 0 goes in the middle. That's the z-score. And really what we're doing is we want the z-score on the left and the right, the symmetric z-scores on the left and right, such that 95% area is in the middle. Remember, 95% is a decimal. It's just 0.9500. 9500. So that stuff in the middle is 0.9500. But remember, inverse norm only does area on the left. So maybe we want to figure out this area over here in this left-hand tail. Well, if there's 95% in the middle, that means everywhere else there's 5%. If we take that 5%, so 100 minus 95 is 5%. Take that 5% and divide it by 2, and that's the area here, 2.5%. 2.5%. So what we do is we do inverse norm of that decimal as a left area, remember? So this is 2.5% is 0.02500. So we do inverse norm. Inverse norm of 0.0250. That's 2.5% on the left. Press enter. And if we round to 4 digits, we get negative 1.9600. So we found out that this z-score on the left was negative 1.9600. This one here on the left. Now if you had to guess what the one on the right would be, it's the same, but positive. 1.9600 positive, because these are symmetric ends of the middle 95%. That's what we're saying, keyword there, middle. So when you get the left one, you know the right one is just the positive version of that. So in these 3 examples, you're using inverse norm to find z-scores. Remember, z-scores are positions, so this time we have areas. Notice that the areas in all these pictures are above or inside the curve, but they're above or inside the curve. And all the z-scores we're finding here are position. So you have to understand position is either positive if it's on the right or negative on the left. Area is just a portion of the curve. This is an area on the right. Inverse norm only knows how to do area to the left. We did a 1 minus here. And then the last one, this was an area in the middle. So since inverse norm only knows the area on the left, we took the total minus the middle divided by 2, did inverse norm of that. Got the other one because of symmetry. It's just the positive version. So keep that in mind and good luck.